All right, so one more video on parallel circuits. With parallel circuits, remember that you have pieces that run parallel to each other, but it really provides an alternate path for current to flow. And kind of like what you found in lab, is that what's kind of strange is that the voltage is the same across each of these branches. And it's because each of them is like they're directly connected back to the battery. So it's different from a series circuit where we said the current all stays the same. It's the voltage that stays the same in a parallel circuit. And then the resistance, that's the weird part too. The resistance actually decreases as we add resistance to or resistors to it, because current has different paths to flow through. It's kind of like adding lanes into traffic. So if you have more lanes for traffic to flow through, that means that you can actually have more traffic. In this case, it's more electrons or more charge that can actually flow through that circuit. And so because we can have more paths, we say that there's less resistance. So only having like one lane of traffic, we would consider that a large amount of resistance if you're trying to fit a lot of current through it. But having more lanes of traffic would be less resistance. Weird, yep. But the way that works is this mathematical relationship, and this is what you got to know. It's this 1 over RP. RP means resistance in parallel. It's equal to 1 over R1 plus 1 over R2 plus 1 over R3. I'll show you how this works because this deals with fractions and then taking a reciprocal at the end. Okay? So let's take a look at an example. And kind of like last time, first thing what you need to do is copy down this table. So the RIV, 2 rows, and the totals. This is what you need to be able to do, and you need to be able to solve this on paper. Do it on paper. It is really hard to remember all the numbers and be able to keep track of everything. It gets messy. So work with me. Copy that down right now. You did it. Great. That's awesome. And so what we do is kind of like last time. We are going to write down the things that we know. And for these resistances, we can just write down just what's here. Like here's a light bulb with some resistance and another light bulb with resistance. So I'm going to put my first one as this 2 ohm and the second one as this 4 ohm. Really doesn't matter which order that you put it in. But because this is parallel, I can't just add up the resistance. It works different than series. So to find the total resistance in parallel, I have to use this relationship. This is on your reference sheet. It's something that you can have on your notes, and you can use your notes for quizzes and tests. And as a reference, yeah, you could do that. But it's this equation. 1 over R1 plus 1 over R2 plus 1 over R3, and you can keep going. But we only have 2 resistors here. So what we do is we take that resistance and we go use it as 1 over this first resistor, which was 2, plus 1 over 4. But here's the thing. Now we are adding up fractions. And to add up fractions, you have to have common denominators. And here in a little bit, we'll take a reciprocal. So let's do this and kind of break it down. We have 1 over 2 plus 1 over 4. First, we need to make sure that we have a common denominator in order to solve or add these together, because 2 on the bottom, 4 on the bottom, we can't do that. So common denominator is a number that these two numbers can get up to that are in common with one another. Like with 2, 4, you could do like 2, 4, 6, 8. 4 is 4, 8, 12, 16, all that kind of stuff. But the number that they have in common or the first one they have in common is 4. We can just leave this one as 1 over 4. But the other one, we can have 4 as the denominator. To do that, though, we have to multiply the bottom number by 2. And if I do that, I also have to multiply the top number by 2, or the numerator. So I would end up with 2 over 4. So that's how I get my common denominators. But now, because I have common denominators, I can just add this together. Just remember, the denominator stays the same, and you're not going to add that together. So it's not 8 on the bottom. It's just 4. You only add the numerators. So the top numbers, you have 2 plus 1, that's equal to 3. And we get 3 over 4. Awesome. But we're not done yet. And so there's more. Because really, when we solve this out, we really solved out for 1 over RP, or the resistance in parallel. We really want the resistance in parallel, which means we have to take the reciprocal of this, or sometimes we just say flip it. And so instead of 4 or 3 over 4, the resistance in parallel is the reciprocal of that. It's really 4 over 3. Now you can leave this as a fraction if you'd like. Some people like doing that, and that's fine. If you'd like to leave it as a decimal, that's okay too. You can take 4 divided by 3. Just go out 2 decimals and you'll be fine. And we end up with like 1.33. So, and that's ohms. That's how I find my total resistance in parallel. And that part's kind of weird, but that's how you do it. You guys can do it, it'll be good. And the other part of the circuit that I know is this total voltage. Sorry, I didn't do this before. Remember, this comes from the battery? Yeah, that's cool. It's at 12 volts. But now it's solving out for everything else. And there's some tricks that you can do here. And so we can do something similar to what we did before. We have our total voltage, and we have our total resistance. To figure out the total current, then everything else kind of runs in a very similar way, where if you're solving for, or if you know 2 things in a row, you're solving for a third, you can use that equation I equals V over R. So I'm going to do that and solve for the I. My voltage in that row, it's 12. My resistance, it has to be this 1.33 or 4/3, however you want to do it. Oops, 1.33. If I take 12 divided by 1.33, I end up with 9 amps for my current. And so now that I have that, and if you solve this out, you use 1.33, you'll probably come out with like 9.0 blah, 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 blah. That's okay. And I used the whole fraction. You got 9. You're in the ballpark. You're good. And now here's the other thing, is solving out for your other parts. You don't have 2 things in these other rows. But it's, remember, parallel circuits are different from series circuits. We used to say for series circuits, current stays the same. It's not true for parallel. It is voltage stays the same. And so sometimes when people see parallel, they like to write same above the voltage, which means that if we know one of the voltages, we actually know all of the voltages. All of these are 12 volts. And it's because each one of these is like, it's completely connected straight back to the battery. Each one of these receives 12 volts of energy. Now that I have that, I can actually solve out for the current. And so I can use the equation I equals V over R and put in 12 volts for the voltage and 2 ohms for the resistance to solve out for the current. If I do that, I end up with 6 amps. I can do that the same way for this one. And I use that same equation, I equals V over R. And my voltage, it's 12 volts. And my resistance is 4. I add those, or divide those, I get 3 amps. And so that's how I fill out that table. If you did this right, your currents should add up to the total current. You have 6 plus 3 equals 9. Again, if you use it in 1.33, it does come out to be a little bit different, but that's kind of how you do it. All right? We're going to do one more, and we're going to try to go through that one a little bit more quickly, but same process. So we have this thing, this circuit. First thing, you copy down the table, RIV, and then we put in the things we know. We know the resistances. This stuff doesn't get written out as fractions. You just write it out as it is. So it's not 1 over 10 and not 1 over 40. It's just 10 and 40. The total voltage that comes from the battery, it's 9 volts. But because this is parallel, I have to use that equation 1 over Rp. It's equal to 1 over R1 plus 1 over R2. You don't have to write that out. Some people like to just go right into 1 over 10 plus 1 over 40. But remember to add fractions. You have to have a common denominator. Common denominator between these is, 40. That works out. So to get 40, I have to multiply both top and bottom of these by 4. So I get 4 over 40 plus 1 over 40 equals, okay, now that I have my common denominator, I can now add this. The denominator stays the same, and I add the numerators. 4 plus 1, I get 5. Now here is where something happens, and you can do this now or you can do it later, but you could reduce this. Some people like to do that. Instead of keeping it this way, you could reduce it as 1 over 8. Either way, it really doesn't matter, because remember, this isn't our total resistance. This is equal to 1 over that resistance in parallel. I need to, before I put it in here, you have to remember it. You have to take the reciprocal. You have to flip this. So we end up with really 8 over 1, or just 8 ohms for the total resistance. You will get that answer whether you reduce this or not, because when you flip this one, you end up with 40 over 5. That's also equal to 8. Either way that you want to do it, though. And then, so now I kind of look at what I got. Well, I can solve out for this current here because I have 2 things in a row. I have 9 volts, 8 ohms. I solve for the current using I equals V over R. I put in the voltage from that row and the current from that row. And I end up with, if you go out 2 decimals, you end up with 1.13 or 1.125. If you want to do that, that's okay. But it's some things that tend to happen is that people will put all this answer in every single one. Remember, in parallel, it's not current that stays the same. It's voltage that stays the same. And this is what you got to make sure that you keep track of. So because I know the voltage in one spot, I know the voltage in all these other ones, because really each one of these is it's connected straight back to the battery. And now I can use that equation I equals V over R in order to solve out for the other I. So I put in 9 volts, divide by 10, I get 0.9. I put in 9 volts, divide by 40, and I get 0.2, right? 23 or 225. And so, right? Yeah. So you get something like this. They should add up to be really close, but that's kind of what you do. Even if you have 3 things that are in here, you can do the same process. You just have 3 resistors that you're adding up, and you have to have common denominators. That's it.